Good morning, friends. Last we discussed about the Rutherford atomic model and limitation of Rutherford atomic model. Now, what is the total energy of electron in hydrogen atom? So here there is the most important question frequently asked. Here is the formula of energy of electron in atom revolving around the nucleus in different orbits for each atom. Because here we have the equation for hydrogen atom. Again, the question is that the formula of total energy of electron in hydrogen atom revolve around the nucleus in different orbits. Now, according to the Rutherford atomic model, entire positive charge and most of the mass of the atom is concentrated in small volume of the atom. This small volume is known as the nucleus, while the electrons are revolved in a circular orbit around the nucleus. Right? So there is the Rutherford atomic model. Again, according to the Rutherford atomic model, the most of the mass of the atom and entire positive charge is concentrated in small volume, that which is called the nucleus. This nucleus is surrounded by the revolving orbit in their respective stable orbits. The electrostatic force of the attraction Fe between electrons and nucleus provide the necessary centripetal force to keep the electron in their orbits. According to the Rutherford atomic model, the entire positive charge is concentrated in small volume. That is known as the nucleus. While the electron is revolved in circular orbit, So here the electron nucleus has the positive charge, electron has the negative charge. So according to the Coulombian force of attraction, the Coulombian force applied on electron by the nucleus, this force is in the direction towards the nucleus, which provide the necessary centripetal force for the electron to revolve in a particular orbit. For a stable orbit of radius r in hydrogen atom, the electrostatic force is equal to the necessary centripetal force. Therefore, Fe is equal to Fc. According to the Coulomb's law, 1 upon 4 pi epsilon 0 is square upon r square. Actually, here the nucleus has the charge is Ze, but for hydrogen atom, Z is equal to 1. Atomic number is 1. Z is equal to 1. Therefore, the nucleus has the charge is E, electron has also the charge is E. Therefore, E into E is square upon R square. Therefore, 1 upon 4 pi epsilon 0 is square upon R square is the Coulombian force of attraction by the nucleus on electron is equal to centripetal force mv square upon R, 1 times R cancel. Therefore, radius R is equal to square upon 4 pi epsilon 0 mv square. That is the equation of radius of the circular orbit of an electron in which the electron can revolve. Again, there is the equation of the radius of the electron for hydrogen atom in which the electron is revolving around the nucleus. So this equation shows the relation between the velocity of the electron to the orbital radius. Now, next is the kinetic energy of the electron in hydrogen atom is half mv square. Therefore, from this equation, what is the value of mv square? Mv square is equal to square upon 4 pi epsilon 0 r. So from equation 1, mv square is equal to square upon 4 pi epsilon 0 r. Substitute this value of mv square in this equation 2. Therefore, kinetic energy K is equal to half mv square is equal to half into mv square is equal to E square upon 4 pi epsilon 0 r. So the kinetic energy of electron in orbit having the radius is r is E square upon 8 pi epsilon 0 r. So there is the equation of kinetic energy of an electron in a circular orbit of radius r. K is equal to E square upon 8 pi epsilon 0 r. And potential energy. Now listen, potential energy is equal to Coulombian force into distance. Negative of Coulombian force into distance. Minus Fe into R. What is the Coulombian force? Between the nucleus and electron, there is the minus 1 upon 4 pi epsilon 0 Zd into E upon R square into R. 1 times R cancel, only minus Ze into E upon R. For hydrogen atom, substitute the Z is equal to 1. Therefore, potential energy is minus E square upon 4 pi epsilon 0 r. That is our equation number 4. Here, this negative sign indicates the electrostatic force is in the direction of minus r. Here, the radius is this. So, S we consider as a vector. So, position vector of the electron with respect to the nucleus is outward direction. But the electrostatic force is act towards the nucleus, therefore potential energy is negative. Or in other words, the negative sign signifies that the electrostatic force is in the direction of minus r. Now, the total energy of the electron in hydrogen atom. Total energy is the addition of the kinetic energy plus potential energy. Addition of kinetic energy and potential energy. Therefore, E is equal to kinetic energy plus potential energy. Kinetic energy is square upon 8 pi epsilon 0 r minus plus potential energy. But the potential energy is negative, therefore minus is square upon 4 pi epsilon 0 r. In both equations, there is common. Square upon pi epsilon 0 r. Square upon pi epsilon 0 r is common. Again, the potential energy is equal to the Coulombian force into distance, and that is the negative value. Therefore, the potential energy is equal to minus 1 upon 4 pi epsilon 0 Ze into E upon R square into R. 1 times R cancel. Therefore, minus 1 upon 4 pi epsilon 0 Z is square upon R. Here, for hydrogen atom, the atomic number Z is equal to 1. Therefore, potential energy U is equal to minus E square upon 4 pi epsilon 0 r. Clear? So here, negative sign in potential energy signifies that the electrostatic force is in opposite direction of position vector or the radius vector. Here, as we consider the position of an electron in particular orbit, so its position vector is denoted by r, that is in this direction, outward direction. Here the electrostatic force is act towards the nucleus, therefore electrostatic force is in opposite direction of minus r. Now the total energy of electron in hydrogen atom is the addition of kinetic energy and potential energy. Kinetic energy is square upon 8 pi epsilon 0 and potential energy is minus square upon 4 pi epsilon 0. Therefore, total energy is equal to square upon 8 pi epsilon 0 plus this value of potential energy minus square upon 4 pi epsilon 0 r. Therefore, E is equal to minus square upon 8 pi epsilon 0 r. the total energy of the electron is negative, this represents that the electron is in bound state with the nucleus. Clear this? Again we repeat this question because that is the most important question for 2 marks. Frequently asked, obtain the equation of total energy of an electron for hydrogen atom. The question is asked like this manner. Derive the formula of energy of electron in atom revolving around the nucleus in different orbit for hydrogen atom. So first, according to the Rutherford's atomic model, the entire positive charge and most of the mass of the atom is concentrated in small volume of the atom. This small volume is known as the nucleus. This nucleus is surrounded by the revolving electron in their respective stable orbit. Right? Like this way, there is the small central volume that is known as the nucleus. Entire mass and most of the mass and entire positive charge is concentrated in small volume, while the electrons are involved in this circular orbit. Therefore, the electrostatic force exerted by the nucleus on revolving electron. This electrostatic force provides the necessary centripetal force. And due to that reason, for a stable orbit in hydrogen atom, the electrostatic force Fe is equal to the centripetal force. According to the Coulomb's law, the electrostatic force is 1.4 pi epsilon 0 square upon r square is equal to centripetal force mv square upon r. 1 times r cancel. Therefore, equation of the areas, orbital areas, r is equal to 1 upon square upon 4 pi epsilon 0 into mv square. So this equation 1 is the relation between the velocity of electron to the orbital radius. Now our aim is to derive the equation of total energy. Therefore, we have to derive the equation of kinetic energy and potential energy. Now, the kinetic energy of electron in hydrogen atom is half mv square. That is equation number 2. But from equation 1, what is the value of mv square? Therefore, mv square taken here, mv square is equal to square upon 4 pi epsilon 0 r. Right? Substitute this value of mv square in equation of kinetic energy. K is equal to half mv square. So is equal to half. Now mv square is equal to square upon 4 pi epsilon 0 r. Therefore, square upon 8 pi epsilon 0 r. That is our third equation. Now, potential energy. Now listen, in our textbook, the equation of the potential energy is given. So how we keep in mind the equation of the potential energy? Potential energy is equal to force into distance. According to the work energy theorem, work done is equal to change in its potential energy. So, potential energy is equal to minus F into R. F the Coulombian force 1 upon 4 pi epsilon 0 into ZD into E upon R square into R. 1 times R cancel. Therefore, potential energy U is equal to minus 1 upon 4 pi epsilon 0 Z square upon R. For hydrogen atom, we substitute the Z is equal to 1. Therefore, U is equal to minus square upon 4 pi epsilon 0 r. Here, negative sign shows that the electrostatic force acting is in opposite direction of minus r. Now, the total energy of electron in hydrogen atom. Total energy is equal to addition of kinetic energy plus potential energy. Kinetic energy is square upon 8 pi epsilon 0 plus potential energy is minus square upon 4 pi epsilon 0 r. These two terms are constant, therefore 1 upon 8 minus 1 by 4, therefore minus 1 by 8 is remaining. Therefore, total energy E is equal to minus square upon 8 pi epsilon 0 r. So the total energy of the electron is negative. This represents that the electron is bound to the nucleus. That means the electron is in bound state with the nucleus. Okay, already we discussed about Rutherford's atomic model and also the limitation of Rutherford's atomic model. Now, Rutherford cannot suggest or cannot explain the stability of an atom because the electron is evolved in a circular orbit, so the energy of this electron is decreases. As a result, the radius of the circular orbit is also going to decrease because during the circular motion of an electron around the nucleus, the electron continuously radiating the energy, or the energy is emitted from the electron. So at last, the electron is terminated in the nucleus. Therefore, the atom cannot remain stable. So due to that reason, the Rutherford's atomic model is failed to explain the stability of an atom. Okay. Now, the Niels Bohr suggested the three postulates or the three hypotheses in Rutherford's atomic model to fulfill the atomic model, right? Okay. The Niels Bohr. Now, today's question is that explain Bohr's atomic model and write Bohr's postulate for atomic model. That is the most important question. Frequently, this question is asked for 2 marks question. Write the Niels Bohr's hypothesis for atomic model, or what is the Niels Bohr's atomic model? Bohr combined the classical and quantum concept and gave his theory in the form of three postulates which are followed. So here Niels Bohr combined both classical mechanics and also the quantum mechanics and gives the three concepts or the three hypotheses for atomic model, or these three postulates are added in Rutherford's atomic model. Because the Rutherford cannot explain the orbit of the electron. So Niels Bohr first suggested, or the first postulate is according to the orbit of an electron. Niels Bohr suggested that electron never emits the radiation or the energy during its stable orbit. When the electron is evolving in a stable orbit, it does not radiate any type of energy. Therefore, the radius of the orbit cannot be changed. Right? Second is, the electron can evolve out of numbers of the orbit only in those orbits for which its angular momentum is integral multiple of h upon 2 pi. So not according to its energy, but the electron can evolve only in those orbits for which its angular momentum is integral multiple of h upon 2 pi. And third postulate is that in which condition the electron make the transition or the electron change the orbit. When the electron make the transition from higher energy orbit to the lower energy orbit, at that time the photon is emitted having the energy is equal to the energy difference between these two orbits. And vice versa, when the electron make the transition from lower energy state to the higher energy state, at that time it absorbs the energy equal to the energy difference between these two states. So after adding the three postulates suggested by the Niels Bohr in Rutherford's atomic model, now this atomic model is fulfill all the requirement for the atomic structure. So we start our discussion about the Niels Bohr's atomic model or Bohr's postulate for atomic model. In 1913, the Bohr classical and quantum concept combined the classical and quantum concept and gave his theory in the form of three postulates as follows. In 1913, Bohr combined classical and quantum concept and gave his theory in the form of three postulates as follows. First postulate is that in an atom, an electron could revolve in certain stable orbit without the emission of radiant energy. And these states or these orbits are called the stationary state or the stationary orbit of the electron or the atom. Again, in an atom, an electron could revolve in the certain stable orbit without the emission of radiant energy, and this state or this orbit are called the stationary state or the stationary orbit of the electrons. Now, which is contradictory to the electromagnetic theory. So, electromagnetic theory not give the permission about this. The electron cannot evolve for the long time in a same orbit. So, the first postulate suggested by the Niels Bohr is that in an atom, an electron could evolve in certain orbit without the emission of radiant energy, and this orbit are known as the stationary orbit of the electron, which is contradictory to the electromagnetic theory. Therefore, according to this postulate, the orbit of the electron are fixed. The electron can stay in particular orbit till it cannot radiate any energy. Now, the second postulate is that the electron evolve around the nucleus only in those orbits for which its angular momentum is integral multiple of h upon 2 pi. Second postulate is that the electron evolve around the nucleus in those orbits for which its angular momentum is integral multiple of h upon 2 pi, where the h is the Planck's constant. Its value is 6.626 into 10⁻² minus 34 joule into second. Thus, the angular momentum L of orbiting electron is quantized. Therefore, the angular momentum L is equal to nh upon 2 pi is equal to mvr. That is the value of angular momentum, and according to the Niels Bohr's hypothesis or the postulate, that is the h upon 2 pi, n is the number of orbit, or the integer number. N is integer. So the second postulate represents the or fix the orbit of the revolving electron around the nucleus. While the third orbit, Bohr's third postulate is incorporated into atomic theory and quantum concept developed by the Planck and Einstein. When an electron makes a transition from its non-radiating orbits to another lower energy orbit, that means when the electron makes the transition from non-radiating orbits to the another of lower energy orbit, a photon is emitted having the energy equal to the energy difference between the initial and final state. Like this way, here is the nucleus. Here the numbers of the orbits are present. As we go away from the nucleus, the energy of the electron is going to increase. Suppose the electron is revolved in this orbit, having the energy is ER. Make the transition from higher energy orbit to the lower energy orbit. There is the ith orbit, there is the kth orbit, having the energy is EP. Here, the energy difference, energy EI is greater than EP. When the electron makes the transition from non-irradiating stationary orbit to the lower energy orbit, so here the electromagnetic waves or the photons having the energy equal to the energy difference is emitted. E is equal to EI minus EF, that is known as the HF. Now, according to the third postulate, when the electron make a transition from its non-radiating orbit to another lower energy orbit, a photon is emitted having the energy equal to the energy difference between the initial and final state, EI minus EF. EI minus. Suppose there is the F energy final. So here the energy is FK, EF. Therefore, EI minus EF is equal to energy of photon. Already we learned about that. The energy of the photon is equal to HF. Right? Therefore, the frequency of the emitted photon is HF is equal to EI minus EF, and therefore F is equal to EI minus EF upon X. Where the F is the frequency of emitted photon, EI is the energy of initial state, EF is equal to energy of the final state. Here the EI is greater than EF. Now again we repeat the Bohr's atomic model. And what are the Bohr's postulates for atomic model? Now in 1913, the Bohr combined the classical and quantum concept and gave his theory in form of three postulates, which are as follows. These three postulates gives or suggests the fixed number of the orbit. Out of the numbers of the orbit around the nucleus, the electron can evolve in which orbit. And third is, in which condition the electron make the transition from one orbit to the another orbit. Right? So this cannot be explained by the Rutherford's atomic model. So these three postulates are added in Rutherford's atomic model. So that is known as the Rutherford's suggestion, or Rutherford's hypothesis, or Rutherford's three postulates about the atomic model. First postulate is that in an atom, an electron could evolve in certain stable orbit without the emission of radiant energy. So electron can evolve around the nucleus in orbit without radiating any energy. Without radiating any energy. And this energy, this orbit is known as stable orbit, or the stable state. In spite of it performs the accelerated motion, but here the energy cannot be radiated by the electron. Therefore, for long time, this electron can evolve in particular orbit without radiating any energy. So this is contradictory to the electromagnetic theory. So according to the first postulate suggests about the stationary orbit. Now the second postulate, the electron evolve around the nucleus only in those orbits for which its angular momentum is integral multiple of h upon 2 pi. Out of numbers of orbit around the nucleus, electron cannot evolve in any orbit according to its energy. But the electron can evolve in those orbits for which its angular momentum is equal to the integral multiple of h upon 2 pi. So here h is the Planck's constant. Its value is 6.626 into 10⁻² minus 34 joule into second. So thus the angular momentum L of the electron is quantized, and therefore angular momentum L is equal to nh upon 2 pi, but the value of the angular momentum is mvr. M is the mass of the electron, v is the orbital speed, and r is the orbital radius. Here the n is the integer value. Now third postulate, or the third hypothesis, Bohr's third postulate is incorporated into atomic theory and quantum concept developed by Planck and Einstein. So this postulate suggests that in which condition the electron changes its orbit. So if the electron change its orbit, what's happened? So what are the radiation take place and what is the frequency of this radiation? So when an electron makes a transition from its non-irradiating orbit, that means when the electron makes the transition from its stable orbit to the another lower energy orbit, a photon is emitted having the energy equal to the energy difference between initial and final state of the orbit. Like to that way, initially the electron evolved in ith orbit, having the energies EI. It makes the transition from ith orbit to the F orbit. F orbit is close to the nucleus. The energy of the electron in close orbit is less. And the orbit is far distance from the nucleus having the high energy. Okay. When the electron makes the transition from higher energy state EI to the lower energy state EF. So during this, the electromagnetic waves is radiated. That means the photons are radiated and the photon having the energy is equal to the energy difference between initial and final orbits. Therefore, energy of the photon HF is equal to EI minus EF. Therefore, the frequency of the photon F is equal to EI minus EF on H. When the F is the frequency of emitted photon, EI is the energy of initial state, EF is the energy of final state. Here the EI greater than EF. Now opposite to that, if the electron makes the transition from lower energy state to the higher energy state, that is the EF, that is the EI. At that time, it absorbs the energy equal to the energy difference of these two orbits. When the electron makes the transition from non-radiating energy state to the higher energy orbit, it absorbs the photon having the energy equal to the energy difference between these two orbits. So in these cases, the electron makes the transition from higher energy state to the lower energy state and lower energy state to the higher energy state. That means the electron can change the orbit by either the emitting or absorb the energy equal to the energy difference between the two states. So that is the Neil-Bohr's hypothesis, or the Neil-Bohr's postulate about the atomic model, and these three postulates are added in Rutherford's atomic model.